Ladies and gentlemen, may I have your attention, please? Our session is about to begin. Please have a nice seat. Thank you so much.
Ladies and gentlemen, distinguished guests, a very good afternoon to you. Welcome to the International Symposium on Wildlife Biodiversity Conservation. We have arrived to the Symposium 6, Partnership and Collaboration in Wildlife Conservation. Thanks to you all for coming. I'm Dian Fatina Aprilia and my partner, Akban Nur Arbani. We are honored to serve as the master of ceremony for this symposium.
But before we start our session today, we would like to announce you that the true guiding force for our symposium will be our distinguished chairperson, so who will lead us through the session and discussion to follow. But before I introduce our chairpersons, I'd like to take a moment to acknowledge and express our gratitude to the organizations and sponsors that have made this event possible. To the sponsor, we would like to thank to April Group, Global Environment Facility in partnership with UNDP, our United Nations Development Program and Combating Illegal Wildlife Trade, Peat and Mangrove Restoration Agency of the Republic of Indonesia, Borneo Nature Foundation, Taprobonica, the Journal of Asians Biodiversity, Fauna and Flora International, Copenhagen Zoo, Kaleka, Action Conservation Foundations, and Persona Indonesia Tours. We are deeply grateful for their commitment to advancing our shared missions of conserving and protecting the incredible wealth of biodiversity our planet possesses.
This session will be expertly guided by Mas Donan. For Mas Donan, please welcome Mas Donan. And place is yours.
Please give us applause of him.
Hello, Assalamualaikum warahmatullahi wabarakatuh. So good afternoon, everyone, ladies and gentlemen. I'm the new chairperson for this session, and I'm Doni Gunaryadi from Fauna Flora International, and I would like to convey these sessions. And during this session, there will be 8 persons. 8 speakers that would like to give their talk for these sessions, and it's very quite diverse informations and also presentation that maybe is quite interesting to see, and some of us maybe would like to know more about, especially with how the ecosystem suitability and also the regarding with the corridors. So without further ado, I would like to invite the first speaker, Dr. Muhammad Taufik Tri Hermawan. Yeah, okay. Please give applause to Pak Taufik. So you will have, in here it's about a 15 minutes talk. Time is yours, Pak.
Good afternoon, everybody. Ladies and gentlemen, let me share our research on developing remeasurement tools for assessing of the effectiveness of essential ecosystem area management in Indonesia. As we know, Indonesia is one of mega biodiversity country. Because of that, Indonesia allocated 27.2 million hectare for conservation area in 2010, and in 2023, Indonesia allocated 27.14. The quantity is increased because in 2010 there are 5,021 unit conservation area. In 2023, 5,060 units. But the area is decreased from 27.2 decrease into 27.14. Okay, yeah. Okay, terima kasih. However, conservation area in Indonesia still found gaps that include representative gaps, ecological gaps, and managerial gaps. To fill this gap, Indonesia proposed the establishment of essential ecosystem area. Essential ecosystem area are ecosystem outside conservation area that are ecologically, socially, economically, and culturally important for biodiversity conservation. Many essential ecosystem area have been established, but the management effectiveness of this area is not widely known. This research study aims to develop a tool for measuring the management effectiveness of essential ecosystem area. In this method, we use the framework of conservation area management cycle. This cycle divided into 6 stages: context, planning, input, process, output, and outcome. Each stage is broken down into various criteria, then each criterion is translated into question about the condition of management ecosystem area. And each question is divided into 4 stages according to the condition: optimal, we score 3, semi-optimal, we score 2, and half optimal 1, and less condition 0. And then after the developing the tool is done, the instrument tested into 2 conservation area and 2 essential ecosystem area. Data collecting using key informant and supplement with related secondary data. Data analysis was carried out by comparing the management condition of the selected area with its tool. This is the result. Development of tool to measure the effectiveness of management of essential ecosystem area. We cyclus of the management effectiveness, context, planning, input, process, output, and outcome. This criteria is derived to the management cycle. Context, we break down into legality, planning, availability of the regulation, suitable for purpose, accuracy of the area design, availability of planning document, availability of yearly planning, input, law enforcement capabilities, resource inventory, number of staff, trained personnel, funding source, budget, certainty, equipment, land use, and so on. And each question we develop 4 option answer. That the situation is optimum. We score 3. Semi-optimum, we score 2, and half optimum, we score 1, and less optimum, we score 0. This is the measurement of the 4 location in Yogyakarta. The difference between ecosystem, essential ecosystem area and conservation area is the first is inventory, directing capacity for management in protected area, conservation area, I mean, yes. In essential ecosystem area, no. Regulation of natural resource utilization in conservation area, yes. In essential ecosystem area, yes, and ecosystem essential area 2, no. Integration of research with management, yes. In ecosystem essential ecosystem area, no. Number of staff in conservation area, the number is specific. In ecosystem area, this is a network collaboration, various of stakeholder, and in essential ecosystem area 2, network management body. Staff capacity building, yes, no, no. Budget security, protect conservation area, yes, and essential ecosystem area, no. Budgeting in conservation area, yes, and in essential ecosystem area, no. The conclusion is the management of essential ecosystem area is less effective when compared to effectiveness of conservation area management due to the difference in the main characteristic of management institution, namely management mandate and institutional solidity. The source of ineffectiveness of management essential ecosystem area are the clarity of the management mandate and the relative fluid institution form. Thank you very much.
Thank you, Pak Muhammad Taufik Tri Hermawan. So I would like to ask, is there any questions or comments from the guests? I mean, for participant here? Yes? 1, 2? Yeah. First, maybe Pak Beno first. Okay, ladies first. Oh, Pak Beno, please. You go first. So, is there any microphone? Yeah, okay.
Thank you, Mr. Moderator.
Yeah.
Mr. Taufik, I have one question. Can you explain how to calculate from the 6 states into conclusion that in protected area is less effective than in ecosystem essential area is less effective than the protected area. Thank you.
Yeah. Okay, Mr. Beno, thank you for the question. In 6 stages of management cycles of essential ecosystem area. I think the different with the conservation area is mainly on the input. When the conservation area, the personnel is clear, the budget clear, and the equipment clear too. But in the essential ecosystem area, usually they're managed by village community. So they don't have a specific personnel, a specific budget, and specific equipment. Thank you.
Okay. Next question from Ms. Namrata. Yeah. Microphone? No, because somebody is online need to hear your question as well. Sorry.
My question is actually very similar to the one that was just asked. I was always under the impression that Kawasan ecosystem essential is not completely managed by the local communities, but it's actually like a multi-stakeholder sort of an approach to. So I would imagine that a multi-stakeholder approach to managing a land, as opposed to just having one stakeholder managing it, would have more effectivity than the other. So I just wanted to understand the analysis, the comparison between these two. How did you come to that? Because for me it's almost counterintuitive to think that a multi-stakeholder approach would be less effective than a single stakeholder approach.
Yeah, in my tool, I test into 2 conservation area lands and 2 essential ecosystem area. One ecosystem essential area is managed by collaborative management, and one managed by village community. But the result is there.
Was there a difference between the two?
Yes.
Okay. So I think because it's about timing, but I think we have to stop the discussions. But because Pak Taufik is here, so we can discuss further. And also I would like to know more, because if you have kind of a paper that already been published for this presentation, I think it's good to have a discussion. Because this essential ecosystem area, sorry, it should be Sharon. Yeah. So actually this is the things that's quite sensitive in some ways, because as you know, as you're aware of, maybe you're aware about that, was because we cannot say that for the KAI itself, it's not like being endorsed fully by the government. It's becoming like the other situation, and I would think that I think this is good to have more discussion. But in terms of effectiveness, because this is something the approach is similar like the METT, Management Effectiveness Tracking Tools, as you see, all the 6 components that he used actually as the same exactly like the METT, and then I think we can discuss further. But so I would like to give applause to Mr. Taufik for this nice presentation.
Thank you very much.
Thank you, Pak Taufik. And the next speaker, I would like to invite Irawan Asaad, ST, M.Sc, Ph.D. Is it online or coming to these sessions? Online, okay. I would like to, hello, Pak Irawan. Okay, can you hear us?
Yeah, can you hear my voice there?
Okay, yes, loud and clear, sir. So,
yeah, I can hear you.
Okay. I think time is yours. We will have a 10-minute presentation, and after that, a 5-minute discussion, Q&A. So time is yours, Pak Irawan. So committee, could you please give access to what
thank you.
share screen? Yeah.
Oh, yeah. Can I share my screen then?
Yes, sir. Yes, Pak. Okay.
Yep. Okay.
Okay.
Thank you, Chair. Good evening, everybody. I would like to share my project on developing partnership to conserve endemic species of Java. I'm Irawan. I'm the head of the Natural Resources Conservation Agency in West Java. And today, on behalf of my colleague Erin Drayana and Asep Pranajaya, I will present this article or this research. Okay, first I would like to take you to the background of this condition. Yeah, so there are triple planetary crises today. First is the climate change, the biodiversity loss, and the pollution. The climate change, you already know that the sea level will rise, the earth become hotter, and everything is changed. The pollutions, plastic pollution, and everywhere, and the biodiversity loss. One of them is one is the biodiversity loss. Why would I to talking about the biodiversity loss? Because it's affecting everything. Yeah, we're living based on the biodiversity, and biodiversity is also affected by the climate change and also from the pollutions. So how to tackle this one of these planetary crises in context of Natural Resources Agency, because we are working under the Ministry of Forestry and Environment. So this is our area in West Java. So we manage like 50 units of conservation area from Banten to West Java. So there are like 28 nature reserve, yeah, 12 tourism park and everything. So we have in here number of this park, and then this park is a part of this home range of iconic, charismatic, and endemic species. In Java, in West Java, particularly, this is 21% of our forest is under the forest cover, and 59% of them is protected areas. As I mentioned before, this forest is part of home range of this, you name it, Javan leopard, Javan hawk eagles, Javan lemurs, Javan gibbons, and there are a number of species living in our forest. So why we need to protect that one? So there's a regulation. So I will talking about this, the rules for the laws under the Ministry of Environment and Forestry. There is a Directorate General decree on determination of 25 priority endangered species. Then we have a target that to increase 10% of them in 2019 until 2025, including the macan tutul, Javan leopard, Panthera pardus, Owa Jawa is Halobatis moloch, and initiate Javan hawk eagles and Rafflesia. There's also a letter of directors of how do you call it, conservation, species, and genetics concerning the direction of implementation of the species in until 2024. So this is the basis regulation why we protect this one. But there is also why we need that one. Why we have to build a partnership to protect that species. The main reason because it's complex tax. Yeah. So we are not only dealing with one species, but there's how many species in Indonesia? More than 1,000, more than 2,000. Yeah, you name it. And then this one is a number of them is endemic species. So it's complex task. The second one is wide scale area. This is spanning from, I mentioned before, from Banten to Ciamis. So it's quite large coverage of forest and 789 hectares, 1,000 hectares of the forest. The third one is high risk, which managing endemic species very high. Yeah, very high channel and challenge and how to conserve them. The fourth one is limited resources. We have limited facilities, budget, and infrastructure to conserve that species. So we build partnership in West Java, Natural Resources Agency. We build partnership with government, private sectors, environmental NGO, and stakeholders. Why we build this partnership? Because what is part of environmental ethics. Now we are talking about the environmental ethics. Why we have to conserve these species? Because it's not only national assets, but also responsibility for us as a human to taking care of this all of this animal in the world. And second one is because there's urgent need to preserve them. As I mentioned before, there is triple case of biodiversity loss. Every day like 20 species that extinct in the world. Yeah. Now there is a wildfires in all of Indonesia, and for sure that one is may extinct some of our species. So there's urgent need to preserve them. The second one is why we build partnership, because previously this kind of activities solely managed by the government or the academia. Now we need to leverage this program to also cover the private sectors, the environmental NGOs, and other government, local government. So that's why we build this kind of collaboration. The fourth one is very important. One is to improve awareness and engagement. How to engage now is the community. How to engage the young folks now that consists of more than 40% of our citizens. So in this case, we call it Center of Excellence. First, there are a number of programs that run now in West Java. So first, we collaborate with Pertamina. With Pertamina, we develop a program named to conserve Javan eagle. So we call that one Kamojang Eagle Conservation Centers. Now this in the tourism park of Kamojang. There's like 8 hectares of area that we dedicated to conserve this Javan eagle. There are currently there are like 150 species in there, individual in our center to rehabilitate. We also collaborate with Aspinal. Aspinal is a British NGOs, and with Aspinal we develop a program to rehabilitate Javan primates, particularly Javan gibbon, Halibetis molo. Yeah. The third one we also collaborate with IAR, Yayasan IAR Indonesia. This one is to protect slow loris, kukang, something like that. Yeah, and there also we also collaborate with local NGOs, Yayasan Jaringan Satwa, to rehabilitate long-tail macaque. Although this long-tail macaque is not the endangered one, or maybe it's endangered in IUCN, but there's a number of here in Indonesia. But previously, this program is the design to conserve or to rehabilitate the topeng monyet one. I don't know in English, topeng monyet, puppet monkey, something like that. So this project previously dedicated to rescue the topeng monyet one, and now it is developed. It's not only to rehabilitate the topeng monyet, but also the wild one that encroach to the community. So there is this we call it one center of excellence, where people could come there to learn and to know how to rehabilitate these species. So and then how many species are already released? Because one of the key important factors or the key successful of this kind of activities is after we rehabilitate the species, we have to release it to the wild. Because this is main goal. We have to release all of the species to the wild. So in Eagle Release Program in Kamojang, currently now there's 120 species, 120 individuals that we already released. And now in our facilities, 143. We still have 143 inside our facilities that being rehabilitated. For the Javan primate, Halibetis molo, Risbitis cormata, and Mauritius and Auritius is like more than 250 individuals that we already released to the wild. For the slow loris programs, the Kukang one, it's like 132, and this also we still have a number of this Kukang inside the facilities. And also with the long-tail macaque, it's like 380 individuals that already released to the wild. So if we see this number, so I always say that we cannot talk about the number, but the successfulness of this release to the wild. This is the location. So there is number of location that we release this species, coming from there's a number from the Cagar Alam until to Taman Nasional. This based on ecological analysis where the exact or suitable location for this species, because this one must be the native area for them. And then what is the strategic steps for the next one? it seems, based on our analysis, that this one is a successful program, 641 individuals that we released to the wild, and with the survival rate 99%. And then the second one is we would like to these collaborative programs. We will need to be advanced to conserve another species, because there are more than we have a number of species that need to be rehabilitated. The third one, because it's not only to strengthen the wildlife population, but also to raise awareness of the community. These are the important things. And the next target, now we are working on conservation on Panthera padus melas, or apa namanya, macan tutul, and reintroduction of we also want to reintroduction program of Bos javanicus, or banteng Jawa. We now in the initiation phase. We hope that next year we will have project to conserve these two species. Yeah, thank you, Mr. Chair, and I hope you enjoy my presentation.
Mr. Irawan, thank you very much for in exactly 10 minutes for the presentation. And I would like to ask any participants offline and also in online, any questions to Mr. Irawan from online persons? Yeah, Namrata, please. So help for microphone, please. Okay, you get it.
Thank you for your presentation, Pa. I'm Namrata from UI. I just wanted to just ask about the survival rate. On how do you calculate your survival rate? What's the period of post monitoring? So after release, how long do you monitor each individual to come up with the survival rate, or is there a different mechanism that you use to identify that? Thank you.
Yeah, please answer the question, Pak Irawan.
Okay, thank you, Namarit. Are you from UI? Yeah. Okay. So yeah, there are different kind of methodology to measure the survival rate, because all of our release program need to be monitored. For Javan eagle, for Javan eagle, 2 weeks intensive monitoring and 3 months of regular monitoring for them. For the macaque as well, but for the macaque it's like a long-term project. For the Halobitis molo, it's like almost 1 month of intensive monitoring, and then like 6 months for regular monitoring. So we count all of them. We reporting. So we have a number of personnel in the field that are working in this release program every day, every hour after the release program. So that's why we count the survival rate of this animal, of this this animal. Yeah.
You have further questions? No. So maybe one question from me, but how big is the area that you manage of this area that for the releasing site? So how big is the area? How big is the area?
Pak.
Sorry?
It's depend. It's really depend on the species. But before we release the species in the wild, so we have a team that analyzes the suitable area for this every space of the species. So we are not only counting the ecological part, but also for the prey, like for the Panthera pallidus prey, and also we have also conduct a survey, social survey.
Okay.
Especially for this big carnivore or big cat. Yeah. So we need to make agreement with the community that they are okay with if we release this kind of species nearby their village, because this one is the key of the survival of the species. Yeah. So it's really depend, but so we can discuss it one by one of this species. Last week 2 weeks ago we released tukang in six individual of tukang, but for tukang it's not really complicated. It's easy because we have forests that they have a prey and everything. But for the Panthera padus melas or for the Javan hawk eagles, we need to very carefully to release it, because they have like a big home range, and then we have to calculate everything before release to the wild. That's why the number is not really high.
Okay. So thank you, Pak Irawan, for this interesting talk. So I would like to give. Oh, one more question from the Zoom. Okay. Okay. I cannot see the question. Okay. Pak Yayan, yeah, please.
Yeah.
Yeah.
Okay. Thank you, Mr. Moderator. Thank you. I mean, thank you, Pak Irawan, for the presentation. It's very nice, very good to know that the PKHD and West Java have some excellent plans to conserve some endemic species in West Java. You've been talking about wild animals more, but in your presentations, you mentioned one target species, that is Rafflesia patma. I was wondering whether you have planned to do some conservation activities or conservation actions or else related to this species in the future, because I did my research on this species. I collected several. I visited some areas in West Java as well, which I might be have some, I can contribute if you have some like initiative or projects related to Rafflesia Fatma in the future.
Yeah. Pak Taufik, sorry, Pak Irawan.
Yeah.
Sorry.
Thank you. Thank you, Pak Yayan. Thank you. So we have one of our area in Pangandaran, Cagar Alam Pangandaran. Is known as a habitat for the Rafflesia patma. And then we invite you to come to our to that park, and we may make some collaboration, because this park, one of the main goals of this park, when we designated this Pangandaran, is to conserve this Rafflesia patma. So I'm encourage the scientists to come to visit our area, and we may make some collaboration, because you know that in our center, or in our agency, there are not really a number of people that understand or have a background in like this kind of plant, particularly for the Rafflesia patma, because endangered species, isn't it? So I might contact you, Pak Yayan, and we can make a collaboration together, because I'm also looking for this kind of activities or kind of collaboration to how do you call it, to enrich our program on conserving this Rafflesia patma. Thank you, Pak Yayan.
Yeah, thank you, Pak Yayan, as well. And then maybe why we have this symposium, to connect people and then broader our networking, and so we can share not only information but also a partnership. So again, thank you very much for Pak Irawan Asaad. I would like to applause to the speakers. And the next one, I would like to invite Reza Pahlevi. Is it online or online as well? Online. Okay. Could you please show the speakers? Hello, Pak Reza. Oh, okay. You're
Hello.
same
Okay.
boat like me. Okay.
Yeah. Okay. Can
We
you
are
hear my
MBA, sir.
voice?
Okay. So I would like to invite Mr. Reza Pahlevi that would like to give the presentation on mangrove ecosystem suitability for tourism activity in Tukak Sadai, south of Bangka Island. So your 10 minutes presentations, Pak, time is yours, Pak. Thank you very much.
Okay. Thank you, Mr. Moderator. Can I share my?
Pak.
Okay. We will discuss about the mangrove ecosystem suitability for tourism activity in Tukak Sadai, south of Bangka Island. So the member is Prof. Erni Pujirahayu and me, Muhammad Reza Pahlevi, and then Arif Febrianto, and the last is Rika Afesia. So as we know that the sea area in Indonesia, especially in South Bangka Regency, is about 10,640 kilometer degree, or approximately 2/3 of the total administrative of area of South Bangka Regency. And the length of the coastline is about 273 kilometer, making South Bangka has a cooperative advantage, yeah, in the management of coastal natural resources, including the mangrove also. And South Bangka has an area of 1955.16 hectare of mangrove forest spread over the several places, including in tukak sadai, also in Leper Island and Pongok Island. Mangrove is in tukak sadai area has 750 0.56 hectare are protected forests. So currently, the utilization of the Tupaksade area as a tourism place, yeah, is about 0.6%. So the ecotourism is a sustainable tourism activity that can provide economic value to the community and local government, but still strive to maintain natural sustainability and protect ecosystem and preserve socioculture in an area. And through natural activity, tourists are invited to see a nature more closely, so that they love more. And in addition, they through introducing socioculture to ecotourism area, including the mangrove also. So the aim of the project is, according to the regulation, of course, of the Ministry of Forestry, the status of protect forest can be used as a natural tourism area with the provision of a maximum area of 10% of the total area. Considering that only 0.6% of the tourism condition have been utilized by the people and government of South Bangka, the community and local government want to make the Tupaksade area wider and more comprehensive ecotourism area. And the current utilization is only from office sketch and local tourism. Therefore, this study was conducted to analyze the potential for the development of Tupaksade mangrove forest as for tourism. So this is the research location of the mangrove bangka. We have some point in Tukaksadai. You can see at the screen, and social activity is seen in some spot such as making the track. We have a track and doing performance for tourist attraction in Tukak Village. So this is the research method that I use. The method to obtain the data was done by putting the track vertically toward the coastal line, yeah, based on the sampling intensity of 0.1%. There are 20 tracks in Sadai and 10 tracks in Tukak. Each of them was divided into 3 zones. We know proximal, medial, and distal for the repetition. And one sample plot size 5 meters times 5 is set up in each zones. Each quadrant is measured with some parameter which are adjusted to the ecotourism criteria. The characteristic and access of the area are directly observed. And then the data analysis use the metric of suitability for ecotourism in the mangrove category. Then the score of tourism suitability index, or we call it as TSI, is calculated and adjusted to the mangroves suitability classes. So this is the how to collect, how to analyze the data. To analyze the data on vegetation, we make sure the density distribution use a formula, as we know that the density is equal to the total number of individual per quadrat unit, and the identification of macroscopic biota is visually observed in the research location, and then is analyzed in forest ecological laboratory in the Faculty of Forestry UGM. So this is the criteria determination of for ecotourism. We have some criteria. There are mangrove density and the number of mangrove types and the number of vegetation species and the mangrove girth and the biota object and the characteristic of the area and the accessibility of the area, and we have value that 4 in mangrove density and 5 in the number of mangrove depth and 4 in number of vegetation species. Mangrove girth is 5 and the object is 3, and the characteristics of the area is 4 and the accessibility is 3. So we make a scoring of this determination, yeah, for ecotourism, and we have 4 score, score 1 until score 4, uh, and the mangrove density in score 1 is under the 5, and score 2 is 5 until 10, and score 3 uh, better than 10 until 15, and score 4 better than 14 until 25, and also so on. And we have a biota object of that. There are one of the water biota in score 1, and there are score 2 has fish and mollusca, and score 3 has fish, shrimp, crab, and mollusca, and the score 4 has fish, shrimp, crab, mollusca, reptile, and the bird. So we have the SI in here, and the SI is the tourism suitability index, and we have NE of there, the number of the parameter from the order, and max the maximum number from one category. So this is the suitability class we have done in this project. Yeah, we has S1, S2, S3, S4, N1, and N2. So the list, the very lowest is the listed suitable is N2, and not suitable is N1, and condition is suitable is S4, quite suitable is S3, suitable is S2, and most suitable is S1. So we make the presentation of the SI.
You have 3 minutes, Pak.
Oh, okay. This is the mangrove vegetation in tukak sadai village. So we has a lot of density in Risopora Makronata. We have 40,000, yeah, 40,000, the highest, and the thickness of substrate, the highest is in plot 1. There is 170 centimeter. So the average is 30,040 480 of density per hectare. And this is the mangrove vegetation in Sade village. We have the number of the highest and the lowest. So the highest in the mangrove vegetation is Rhizopora macronata, which have density 40,400 per hectare, and the lowest is the Brugurea gimorrhiza. It's about 400. So this is the mangrove suitability for ecotourism. We have parameter the last I present. We have in sadai and tukak. We have score 4, and in the vegetation density, and we have score 1 in the number of vegetation group, and we have score 2 in the number of vegetation species, and in the tukak we have a score 1, and the sadai we have score 3 in mangrove density, and we have score 2 in tukak, and we have score 3 in biota object, and in sadai, and we have score 3 in tukak, and so on. Yeah. So from the analysis result and the decision, it can be concluded that the score of the tourism suitability index of TSI in Tukak is 60.71%, and in the Sada is uh, 60 68.75%. It means that the score belongs to suitability class in S4. That means condition is suitable to get a higher TSC score. Future research may add the number of the sample plots uh, to increase the sampling intensity in the same place. Okay, maybe that's all my presentation.
Yeah.
I'm going back to the moderator.
Yeah. Thank you, Pak Reza, for the presentations. I would like to ask only one question from the audience here or from the online audience. Okay, one question. Could you please say the name and also the affiliations?
Thank you. I'm Syaiful Anwar, Pak. Just want to know about the correlation, of the diversity of the mangrove and also the aquatic biota. Did you conclude that the diversity of the aquatic biota and also the mangrove have correlation maybe with the high diversity index? There are a lot of benthic maybe, or maybe phytoplankton or zooplankton, and also the nekton as well. And then maybe I didn't see the quality of water maybe in this observation, but maybe there are a lot of reference or maybe the research about the correlation between the water quality in the area of this project, yeah, and also the diversity of the mangrove and aquatic biota. Maybe that's it, Pak. Thank you.
Yeah, please answer the question, Pak Reza.
Okay, thank you, Mr.
Saiful Anwar.
Thank you, Mr. Saiful Anwar. I will answer the question. Okay, there is relation about the biodiversity of mangrove and the aquatic biota. So, and I have some projects beside the ecotourism mangrove, but I didn't analyze. I didn't analyze the project, so I can share on this presentation. So I have the data, the correlation about the how the biota in mangrove is very very have impact, very have impact in the mangrove, yeah, in the habitat of mangrove. So maybe next time I will share the result of the project of all whole of the research. Maybe that's all my answer.
Time, I think we have to end the sessions. So again, thank you very much for this interesting talk. So thank you very much. Would like to give the applause to Mr. Reza Pahlevi. Okay, I would like to invite the next speaker, Wegig Kullusyahi, I'm sorry, that would like to give the presentation on the vegetation propagation ability of selected eucalyptus species for essential oil in khdtk wanagama. Oh, you are replacing him. Okay. What's your name again? Yeni. Okay. Oh, okay. Could you please to the front? Yeah. So Mrs. Yeni would like to give the talk on behalf of Mr. Wegig Kullusyahi. So it's about 10 minutes talk and then 5 minutes question and answer. Yeah, time is yours, ma'am.
Okay, Mr. Chair, thank you for the time. Good evening, ladies and gentlemen. Today I will deliver this presentation on behalf of my team, which work on propagating our eucalypts collection, which has potential to be in the medicinal plants. Next, please. Okay. In plantation industry, eucalypts is known for its wood because the wood is good for both the carpentry and the pulp and paper industries. But after the COVID-19, start from the COVID-19 pandemics, people worldwide enters new paradigm of to live healthier, and it is when the needs on medicinal plants come into attention. Okay, next. Okay, regardingly, it is important to exploit more on any possibilities that our plants are potential for this purpose. So wanagama, the forest research station belongs to the Universitas Gadjah Mada and is managed by the Faculty of Forestry. Already have the collection of both exotic and the indigenous eucalypts. Then this one, we have the species trial planted in 1985. 1985. Now it's more than 40 years old, and it's actually consisted of 14 species, but now recently is only 8 species left. Okay, please next. We can see here, this is the origin of our collections. Many are come from the Australia. Some are from the Western Australia, also from Queensland. We have also another species from the Papua New Guinea, Philippines, and also indigenous from the eastern parts of Indonesia. Okay, next. Next, please. Yeah. Yeah, after many years, this is the individual survival in our species trial. We only have 8 species left. Okay, next. Yeah. Another team in the same faculty of forestry, a team from the forest product department has discovered that several of our collection has antipathogen activity. So we can see here that Eucalyptus tricornis, Eucalyptus decluta, and Uropila we extract the oil from them, and we found that they are effective as insecticides for Coolexia, the vector of filariasis, and then the eucalypt camaldulensis are effective for the Escherichia coli bacteria, and both eucalypt camaldulensis and eucalypt citriodora oils are the best for the inhibition of SARS viruses, including COVID. Okay, next. Okay. So since we found this that best species for the medicinal plants, there are need to propagate this plant vegetatively, so they can copy the same genotypes as the parents. So it can answer the demand on the planting materials is after the COVID-19, the demand on these eucalypts are rapidly increased. Okay, next. So regardingly, our objectives is to provide eucalypt planting materials as well as to maintain the genetic composition of the parents. So this research was focused on determine the vegetative propagation ability of 5 eucalypt, which produce essential oils. Okay, next. For the methods, we have 2 procedures. First, we have to estimate the sprouting ability by making the curdling. After the curdling execution, we wait for more than 3 weeks, and we can start to observe the shoots. And after that, we will estimate the rooting ability by make the shoot cuttings. Here we have 2 kind of hormone treatments. The first are no hormone, just aqueous, and the second are we apply the natural hormone by give it with the onion extracts, and we plant this in the 2 type of media. Okay, next. For the curdling success, it's quite good here because the Europeola, camaldulensis, and tereticonis has 100% success in curdling, but and the citriodora fail to produce shoots. Okay, next. And when we make a measurement on the shoots, we found that Tereticornis has the highest sprout abundance and also the sprout length, as well as the number of leaves per sprout. But the bigger sprouts on the bigger shoots are produced by the Declupta. Okay, next. And this is the shoots or sprouts emerge from the curdling 2 months after the first curdling. Okay, next. Okay, next. Yeah. After we collect the shoots, then we make the shoot cuttings, and 8 weeks after the first planting of the cuttings, we found that actually the Declupta, the eucalypt Declupta are the best one for the cuttings, with the highest rooting ability in all of parameters, including the survival, the root length, and also the number of leaves formed. Next. Okay. From this result, we conclude that Eucalyptus europaea, camaldulensis, and tereticornis produce the highest curdling survival, but Citriodora fail to produce the shoots. And the tereticornis and europaea produce the most abundant sproutings, but are smallest in diameter. And contrastly, Declupta has the fewest and shortest sproutings, but were bigger in diameter. um, when we continue to make the shoot cuttings, the best are the eucalypt declupta. So from this result, we recommend next. So these results provide the initial step on finding the most effective techniques for mass vegetative propagation of eucalypt. But further research, further studies are recommended for arranging better improvement strategies for these selected eucalypts. In example, selection, breeding, and gene recommendation, hybrid, to provide the superior parents for the mass production of the best genotypes for essential oil purposes. Okay, next, this is the end of my presentation. Thank you very much for your attention.
Thank you very much, Mr. Sen. Plus to Mrs. Yeni. So you may stay here for the question and answer. Yes, Mr. Beno. So somebody give a mic for him.
Okay, thank you very much this opportunity. Mbak Yeni, I have one question about this presentation. I always use hormone. Why use hormone in the early propagation? This is the special reason, or maybe this is a tool to increase the early growth for the propagation. Thank you.
Okay, thank you, Pak Beno. Actually, we have run some preliminary studies. At first, there are many hormones. But with the various price, very fluctuated the price from the the cheapest to the most expensive price. We have the NAA, IBA, and in the intermediate we have Eroton F. But also we try the onion extract. But from the results, after many replication, we found that there is no significant result. So why we have to buy the 6 million hormones if we can make the similar effect with the onion extract? And even I have a consult with a friend, a colleague from the RAPP and the MHP, Musi Hutan Persada, and they start to have no hormone at all. They just said, why you can use just water. They will have some effect as long as you manage the humidity. So this is the key, humidity management. So now our lab start with only have the onion extract from the hormones. And believe it, there's no significant result in compared to the most expensive one.
Okay, I think this is great discussion, and then I'm sure somebody will also ask you to have that discussion, and then it's quite interesting that the onion can help. And maybe for your information, because there is a forum Pohon Langka Indonesia. So this is the forum actually for threatened tree species, and one of the challenge actually on how to do that, like you did the propagations.
Yeah,
and in some point maybe your solutions will be one of the options.
You just take it from the kitchen, from your kitchen, so no need to pay much.
Yes. Okay. Thanks again to Bu Yeni. So I would like to give applause to her. Thank you very much. So next, I would like to invite Mr. Yayan Kusuma that will give the talk on genetic diversity and structure of Hopea balitonensis, an endemic dipterocarp from Belitung Island, Indonesia. So I can see that you're there already since the discussions. Okay, time is yours, Pak Yayan Kusuma, for about 10 minutes for the talk. Please.
Thank you, Mr. Moderator. Please let me know if I pass my time allocations, because I'm gonna need a little bit more time to present my study. So actually, this is Can you see my slides? And is it
Yes.
already in the correct situations that you can see my slideshow, yeah?
Yeah, I can see your
Okay, good.
presentations.
Okay, it's not presenter's view, yeah? It's like
Yeah.
audience view.
Yeah.
Great. So thank you. Thank you for the opportunity to be part of this symposium or this conference. There have been so many talk about wildlife, about animals. And now I'm going to talk about plants. I'm going to talk about genetic diversity and structure of Hopea belitonensis, an endemic dipterocarp from Belitung Islands, Indonesia. It's a joint collaborations from some research centers in Green, where I work, and also my colleagues from Japan, from Kyoto University, and also from Tokyo University. And from, maybe you know, most of us actually familiar with dipterocarps. There's this timber family, mostly sought after for the timber, the quality of the timber, and it's predominantly abundant mostly in lowland tropical forests, especially in Sumatra and also in Kalimantan. And you can see in the heat map here, it's actually the distribution is very wide, not only in Asia, but also in Africa, in terms of the family, yeah? Not in the genus or species, but in terms of families. But the highest or the darker the colors, we can see that the most diverse species are exist in Southeast Asia, especially in Indonesia and Malaysia and also Brunei. Just a second. And wait. And you know that even though it's very common, actually it's very widespread in Indonesia, but it's also very threatened due to many things. We can talk about this later. And you can see as well from this map that the most threatened number of species are exist in Southeast Asia, especially in Malaysia, Indonesia, and Brunei. So we've published in these collaborations projects between many researchers from Southeast Asia, from Indonesia, Malaysia, Brunei, Singapore, and also from the UK. We report of the red list of Dipterocarpaceae in here. So we assess all existing available species of Dipterocarpaceae, and we found that out of total species of Dipterocarpaceae, around 67% of them are belong to the threatened category, either critically endangered, or vulnerable, and around 29% are not threatened, and only 4% are still limited of data available that needs to be studied, to be seek after, to do more assessments of them. And if you see that out of those countries that the dipterocarps can be found, we can see that Malaysia has the highest number of species and also highest number of threatened species, followed by Indonesia and also Brunei Darussalam. And what is the main threats of these groups? Mainly, you may already predict agriculture, or we can say that this is mostly because of conversions, habitat of forest conversions into agriculture areas, followed by logging and wood harvesting, because the dipterocarps goods as a timber, so they harvest them for their timber, and also urbanizations. Again, this is related to the habitat or forest conversions, as well as roads, forest fire, of course, in Sumatra and also in Kalimantan, and other causes. And also same situations happen with the Hopea belitunensis, locally known as pelepak. It's a small tree endemic to some islands on the east coast of Sumatra and northwest of Malaysia. So not only in Indonesia and Sumatra, but also in northwest part of Malaysia, especially on sandy soils in Belitung Island and also on limestones in Perak in Malaysia. And it has a critically endangered conservation status. So it is not only narrow endemic, but also limited number of population and higher threat situations. And as you know, the dipterocarp species are relatively common in the heat forest, but apparently they are rare in Belitung Island. So some studies try to do some forestic inventory. They didn't find any individual of Hopea belitunensis, especially in heat forest. And the forest covers in these Belitung Islands already decreased over the past 25 years, or even a long time before, because it is known as so mining companies already operated since the Dutch colonizations in the past that converted most of the forest area in there. So it's already become 2 to 14. So that's why the populations are already decreasing hardly. And habitat fragmentation is also very detrimental, especially for the populations and also genetic diversity. And the declining of this population size could directly cause the loss of genetic variations, genetic diversity, which might have like short and long-term detrimental effects on the population fitness and viabilities. And that is why our study is to examine the population demographic structure of this Hopia Belitunensis and to examine the genetic diversity and structure in Belitung Islands, especially to support its conservation, particularly ex situ conservations, and to compare genetic diversity and structure among 3 different life stages based on our population demographic structure. We classify as mature individuals, juvenile, and also seedlings. So the study areas are in Bukit Ramun, it's conservation and tourist area managed by local community at 129 meters above sea levels with 115 hectares area. We did like reversive sampling for population demographic structures. We also collected the leaf samples, around 74 samples, consists of 25 mature individuals, 16 juveniles, and 30 seedlings. We use MICSEC, so it's like PCR-based next generation sequencing, and then we do the SNP pollings using stacks, and we got like 595 polymorphic loci for mature individuals, 564 polymorphic loci for juveniles, and 742 polymorphic loci or SNPs for the seedlings. And we use this structures analysis as well and determine the clustering based on the delta K values, and you try to visualize with pop helper. All analysis were done in the software of structure and also R package in case we use R package for the analysis. And for the results that we found like 196 individuals in total of 10 to 20 by 20 meters plots with seedlings quite dominant. But more dominant is the juvenile. So the demographic structure of the population is like a hump shape, and it's indicating that it's not like it's a inverted shape, which indicating that successful of regenerations. We saw that the regenerations during seedlings, it's not really either it's not really successful, but the deaths during seedling phase is very high. So it's already reported in several species of Deuterocarps that only around 30% of seedlings can only survive its generation. So that is why the number of seedlings in some times will be lower than juveniles and also in the mature stage, which is quite different compared to other populations that are found in Malaysia that depicted an inverted T-shape, indicating a very good in regeneration situations. And when we talk about the genetic diversity and structure, for genetic diversity, we use several metrics like nucleotide diversity, expected zygosity observed, and also we try to calculate the inbreeding coefficient. We show that there are some variations, even though we know that from our data that the genetic diversity in general is lower in seedlings, quite higher in juvenile and also in mature, but very low in the seedlings phase. But it shows that the genetic diversity actually, if we show the mature individuals, if are quite comparable with other species such as Soralia clausula, Parasoria tomentola, and also Dipterocarpus gradiso, Florus, and also Vatica pantamensis in Java, but much lower than other Dipterocarpus species that we found in mostly in Borneo. And the inbreeding coefficient that we've observed to be very low, indicating that inbreeding the population is not quite prominent, which is very surprisingly because this Hopia is known to be mostly predominantly selfing. So actually we need more studies, more research to know why the inbreeding depression is not really observed, even though most cases that the species is predominantly selfing. And we do the clustering analysis. We found that after several runnings, we found that either in all life stages that the 3 different clusters were detected, even though in seedlings and juvenile, these clustering, these variations of the genetic groups are quite prominent, divided into 3 different groups. However, in the mature situations, in the mature life stage, more samples were predominantly admixture. It's a combinations of different genetic cluster or genetics groups. So the clean genetic cluster in seedlings and juveniles indicating that's potentially due to some like incoming gene flow through pollen from other sources of populations that somehow some kind of shape of like environmental factor or might be a genetic situation could separate the populations into different genetic clusters. So from these studies, from our studies, we can take some messages that the genetic diversity of Hopea belitonensis is relatively low compared to other Dipterocarpus species that we found in mostly in Kalimantan. But the lower genetic diversity in early regeneration stages, such as in seedlings and juveniles, raise some concerns over potential declining in genetic diversity in the populations in the future. That is why like conservation actions, particularly improving the genetic diversity, it will be needed in the future to how to stabilize or improve genetic diversity that might happen in the future. And the genetic structure that we detected during the regeneration stages could also be used as a guidance that we can also use them as a source for ex situ conservations. So because we need to represent all the genetics group, all the genetic cluster in the wild to be conserved in the ex situ conservation. We have already some ex situ living collections in Bogor Botanic Gardens, but it's only from one population. So we still need to somehow incorporate other genetic clusters that were found in the wild habitat on the wild populations. And this genetic cluster can also need to be represented if we want to take action, such as doing some, like it's already critically endangered, and the population number is not so high and also very fragmented. We need to do some reinforcement, or we call it as a population increasement or population enhancements by adding more populations, by doing some more initial new populations in addition to what the populations exist at this moment, because having more populations in the wild might also help them to improve their genetic diversity in the future. So thank you very much, moderator. That's all for my talk. Thank you very much.
Thank you very much, Pak Yayan. Please give applause to Mr. Yayan Kusuma. And we still have one question for the discussion from the audience here or from the online audience. Do you have any questions? From online? Okay. If not, then I would like to ask the question to you, Pak Yayan. This is quite interesting for critically endangered species, and I'm sure that you're aware about some of the action plan for the threatened tree species, also supported by BRIN before it's LIPI, and there are at least 10 or 12 tree species, and then I'm sure because like your approach on this genetic diversity can be also being implemented to the other tree species. And my question is relating with the previous talk on the how to do the propagation. So what is your strategy on increase the diversity of genetic for this species?
Yeah, thank you, Mr. Moderator. Yeah, I'm also part of this Forum Pohon Langka Indonesia. So yeah, I was part of the first initiations of this forum actually, but I'm not part of the author who wrote this conservation strategy for this 12 threatened tree species. However, related to this Hopea belitonensis, after we did our sampling or our study, there were some follow-up studies that tried to collect more samples and more populations, and we found actually more populations in some part of the Belitung Islands. We only used one part of the island which is close to the local botanic gardens there, but apparently there are more populations. We haven't done any genetic analysis on that, but we pretty much quite confident that it will add up the genetic diversity that were assessed, but that we already assessed, that we presented today. But however, from my point of view, improving or increasing more populations in the wild, especially, like in generally when we do the restorations, there is already regulations for that. But there is a tendency that combining what we call as population enhancement or improving populations of endangered species in collaborations with doing some restorations of some degraded areas, it's a good approach not only to restore the habitat, the degraded habitat, but also to improve the such as critically endangered tree species. One of good solution is to also incorporate or involving this Hopi abilitonensis in any restorations project or any rehabilitations projects that might needed or might take place because there are so many ex-mining in Belitung Island. So incorporating the species, it will be helpful not only to improve the populations, but also to improve the genetic diversity, as long as, again, we also incorporate any possible genetic cluster available in the wild populations.
Yeah. Okay. Thank you very much, Pak Yayan, because of the time limitations, and I'm sure also, if I'm aware, also you will be on the next symposium room, right? So
Oh yeah, apparently actually I haven't had. I already told the organizer that we might not be able to do that because of some situations.
Okay.
Actually, my colleagues will present them, but he had some situations back in her family, so we cannot manage that.
Okay. Thank you, Pak Yayan, for this interesting talk.
Thank you very much for the time.
Please applause to Pak Yayan for the talk. The next one, I would like to invite Dr. Yossa Istiadi. If I'm not mistaken, this is one of my friend before. Mr. Yossa Istiadi, are you there in the online? He would like to give the presentation on ecological corridors development design, Gunung Halimun Salak National Park. Hello, Pak Yossa, how are you?
Okay, fine, thank you.
Okay, you have 10 minutes talk presentation, and after that we will give 5 minutes Q&A. So the time is yours, Pak Yossa.
Okay, thank you for Mr. Committee or the moderator. Thank you also for this opportunity. I will take my presentation also. Okay, my name is Yossa Istiadi from the Environmental Management Study Program, postgraduate school from Pakuan University, Bogor.
Pak Yossa, can you enlarge the presentations because it's maybe full screen? Yeah. Yeah. Okay. It's clear.
Okay. Thank you. But the first, I will thanks to this opportunity to can give information or collaborative in the cooperation about research. This just the preliminary research from the bigger one to maintain the ecological corridor in Gunung Halimun, Gunung Salak National Park. This moment is the critical situation from the two forests with the spread from with the area and connecting by the corridor. I mean ecological corridor. Yeah, to create the mobilization canal like that, and we have tried to observation to can make the design to implementation of the maintain the ecological corridor in Gunung Halimun Salak National Park. The first is the disturbance with the habitat area in the West Java, mainly is the very destruction, and maybe this area just remaining habitat to give to conserve to how to animal or wildlife can survive in this area with the limited resources, and this area will be the abundance population, because then in this area is the shape the mobilization of population from Halimun to Salak or from Salak to the Halimun. But the current condition is not so so good, because there is the existing the road, the main road from the district Bogor to Sukabumi, and will be encroachment, for the forest in the next year. This problem is research just to to analyze influence the primate species, also the bird species, also the leopard, Javan leopard, like their species make the mobilization high in the area, and juga also the kind of model for development of conservation for sustaining population animal. We use the methodology just of description survey in population, some birds, primates, and other mammals. We recorded from the September until February 2023. We can use the usually method transect, belt transect. We use the main road across the forest as the belt, and the intensive point account to analyze the birds and account the rate, just to create some opportunity to check the leopards existing. And data collection is determined by setting observation every 100 meter on access roads in the forest. Like this picture show take the mapping of the area collection data in the main road across the corridor area. Maintain cross corridor area about almost 10 kilometer, and we can take the area observation just 1 kilometer, so as long the main road in the forest. Start discussion. Just the animals who can often we observe in each observation period, mainly for the Owa Jawa, Javan gibbon, the small, and then also Javan hawk eagle, Spizatus bartelsi, and then Surili, called lengur leaf monkey, Javan, and Panthera pardus. We call the main animal to conservation target. We saw the existing main road across the corridor area. We can see the width of roads about 3 or until 4 meter, and also established road. This is the public transportation and the public access. The simple access from Bogor to Sukabumi without the Ciawi road. Yeah. One of analyzing is estimation the satellite model, or like the island biography theory. Some of the observation show how the animal can migration or distribution in the forest, and the other pets in out of the forest. We can call the pets habitat. In the models will be to get next analyze to how can the mobilization can create the integrity sustainable population with the migration from Halimun and to Gunung Salak and its other. From the research observation corridor is the access of road. It can be disturbance to the sustainability population, also the species Bartelsi, Javan eagle, and the surili, or Javan gibbon, and Panthera pardus. Some encroachment of the mangrove is how the vehicle passing in the forest corridor will be the 15% truck or 2% car and 50% motorcycle. It can be give some noise or some encroachment to the population. The population migration model in corridor area of Mount Halimun is categorized in the satellite model, and we can move to next research to can create the sum of the managerial system with the local people and other researcher and some the government to take some management plan to save the corridor Gunung Halimun Salak. About the animal mobility indicator, we can use the 4 type. We can use the type of the model migration in the population. Also, but we can show the northern region. This corridor is important habitat patch area. In this case of the observation is might be to get some opportunity to the next research to create some action in how to will be cooperate with other
Yeah, you have 2 minutes.
other people, other party to get some sustainability forest. Also, several consideration for designing ecological corridor maybe will be include, yeah. The first is providing accommodation for the migration of conservation target animal. That means how to can make the tight conservation, yeah, for the migration of the animals. The second, edge effect characteristics. Some encroachment in the main roads. The third is making ecotourism design will be created. Fourth, utilization and non-conservation target species. Other species will be some other birds or some the small mammals. The fifth, modification of habitat infrastructure. In this case of the means, in the next research will be create some how can create the new habitat to modification of the support the animal distribution. Conclusion for this research: endemic plant population of Halimun Salak corridor influenced by the edge effect factor to cause road access. Then for the Javan eagle population, there have 3 patch area around the corridor area. We set the satellite model for mobility between habitats. The presence of large mammal, such as leopard, which is indicator of conservation target in the largest of the forest. Fourth, model of the development of conservation corridor area is designed on the accommodation for the population endemic and threatened species. Finally, thank you for this kind of attention from participants.
Yeah.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
I give
Thank you,
to
Pak
the
Yossa.
moderator.
So applause to
Thank
Pak
you.
Yossa Istiadi for this quite interesting talk. Maybe because of the time, I would like to ask only one question from the audience and also the online audience. Do you have any questions? No? Okay, from online? Okay. So thank you very much, Pak Yossa, for the great talks, and
You're
also I
welcome.
would like to ask everyone to give applause to Pak Yossa.
Thank you.
Thank you very much, Pak Yossa. The next one, I would like to invite Kristana Printers Makur. Am I correct? Okay. Nando. So your real name is Kristana. Oh my God. Okay. Sorry, Mr. Nando.
You can call me Nando.
Nando. Okay. That he would like to give a talk on peran perhutanan sosial dalam skala konservasi multi pihak di bentang alam Rungan Kahayan. So 10 minutes, Mr. Nando. Thank you.
Okay, thank you for the time, and I want to say thank you for the opportunity. So I stand here, and it's great opportunity for me to share the information about rules of the social forestry in a multi-stakeholder Rungan Kahayan landscape. So it's not my expert, but I wanna try to the best because in our team is like goes to Lilik Sugiyarti. Next. Okay, for the introduction, I wanna say Borneo Nature Foundation have 3 locations. Activity. First one is goes to the program Barito Hulu. We work together with the coal company is PT Daya Bumi Karunia, and the second one program Rungan Kahayan. So the site is Kota Palangkaraya, Kabupaten Pulang Pisau, and Gunung Mas. And the last one is program Sebangau. We work together with the Sebangau National Park and the Laboratorium Alam Hutan Gambut with UPR, Palangkaraya University. Next. So, okay, for the program Rungan, I want to talk about the Rungan Kahayan because I work in this site. The location is like between Rungan and Kahayan River. The total is like 150,000 hectares. But we work together with the forest management unit Kahayan Tengah. But unfortunately, it's like a production area forest. But we wanna try to protect the area because we wanna try to give a home for the human, plants, wildlife, and empower the communities around the Rungan Kahayan. So next, the best why we try to protect this area. Next, because this habitat from the orangutan. So we already make a research in 2018 until 2018. We find like a big orangutan there. So from this situation is unique. This area is like production forest, but inside is like have a orangutan umbrella species. So what we do? Protect it or production. Next. So we wanna try to the 2 scenario. First one is like the multi-stakeholder forum. We wanna try how manage the area because in their area we have a lot of multi-stakeholder. We have a government, we have a social forestry, we have a company, we have like a concession, and we have academician there. So we wanna try to make a Rungan multi-stakeholder forum. And another one is like too many function inside for the education, for the protect and use the area, and for the ecowisata. So we want to try to focus on the social forestry because I think the community is a big impact for the conservation. So next slide, please. So social forestry we have in the Indonesia for the regulation number 9 for 2021, we have a scheme for the social forestry. So first one is like a village forest, community forest, community in industrial forest, adat forest or customary forest, and the last one is forest partnership. For now, BNF work in 3 scheme, goes to the village forest, community forest, and the customary forest. In Indonesia, we have a target 2 million hectares for the social forestry. But now we only have like 6 million hectares. So it's like our homework for make sure it's possible. Next. And before we will talk about the social forestry, we want to try to assist in proper social forestry permit. So first thing we do is like a Padiatapa or FPIC. We discuss with the communities what they want and what they think about the program about the social forestry. And the next step, we try to the identification about the status area and overlap the map with the PIAPs. PIAPs already Namrata told about peta indikasi area perhutanan sosial. And after that, we want to go to the ground check because we don't know the situation the area. And as you know, maybe sometimes we find the territorial conflict with the community, so we make sure what we do is not to take their land. And the one thing is access for the social forestry is different with the in central Kalimantan because social forestry is far away from their village, maybe 10 kilos or 15 kilos or something like that. And then if they agree, so we make agreement and ask about they already understand and have a commitment about the social forestry. And then we work together with the FMU to send all documents to the BPSKL, and then we find the decrease of the social forestry. Okay, this the picture. Sorry, this the picture we want to try to assist the villagers for the social forestry. Next. So until now, in the Rungan Kahayan landscape, we have 39 social forestry, but for the BNF, we already assist for the 21 social forestry. And 3 August 2023, we finally have a customary forest. So in BNF already success for the assist the community to have the customary forest in Central Kalimantan. And for the what we do for before get the permit, now we have a 40.14%. It means like a 3 social forestry for the assist for the make a new social forestry, and 19 social forestry we assist now. Next. So why we think about the conservation about the social forestry? For the BNF, now we have like 29,103 hectares, and we have a time for the protect is like 25 years, 35. So before the regulation change, we already protect this area until 35 years. And for now, this the situation in our landscape. And then after that, we make a zonation for the social forestry area. For the protected area, then use area. It's why it's good for the community. They have a challenge for the protect and they use their forest. Next. And after that, we never not only think about the before and after. It's a big challenge. So for the regulation, still for the regulation, we have like a 9 step for the social forestry. But for the general, we must the socialization for the community, not only the community, the village, but the other village, because the next step, they make a boundary. So make sure every people know about the social forestry, and then we make a boundary. And before we make a business, we must know about the potential, the forest. So we talk about the survey potential area, and then we write about their master plan, and then their regulation for the social forestry. And the important thing is how about the business unit for the social forestry. It's big challenge because we want to try to find out the alternative community for the people. And we try to get a collaboration with other partner for them. Next, please. So, in the social forestry, they have 3 sections, like for their organization, protecting and save the forest, and then the business. I think it's like have a connection with the conservation. They try to the protect the area. They try to use. So it's our opportunity to work together with the social forestry. Next.
You have 2 minutes.
Oh, okay. So it's like I just want to show the picture then about what we do. First, we make a socialization, how to they know about the social forestry. Next. And then we want to give a training for them about the social potential survey, because it's their forest, so they do it for their forest. And we give the expert for the make sure we can get the data. And then next. And then we like make a survey potential. We want to say thanks for the Namrata and Ari to support us about the data for the future. We hope give the data to us for make sure we improve the data for this scheme. Next. Next. So this why we protect the area. We give a training for them about the patrol, not only for the illegal activity, but the fire patrol, and then for the biodiversity patrol. And then we make a boundary with the community and make a patrol for the biodiversity. Next. And now Palangkaraya or Sentra Kamera goes to the fire. So we wanna make a patrol for the special patrol for the Karhutla. Next. And for the community development, we wanna try to improve the villagers about their livelihood or something like that, like the bee or the ecotourism. Next. This like a documentary. We already give the expert for the support the activity in the social forestry. And next. This is our homework about the opportunity for the wildlife corridor multi-stakeholder. For the discrete is indication area for what we do about the corridor or KAE or something like that to protect this area, because we already have agreement with the community to protect this area. Beside this area is like a concession, but the one concession already try for the restoration ecosystem for the future. So it's like a connecting them. And we have education forest there. So we used for the library for the how to manage the forest. And the important thing is like we need the government for the budget, because the NGO only have a limited, but for the government I think it's like no limited. Next. The conclusion is like first one is like the community is an important actor in the nature conservation. The second one is like social forestry management is carried out by the community who already understand the important role of the forest for the community as a unit currently. And the number 3, BNF has assets 21 social forestry schemes with the total area of this, And the number 4, the assets provide includes increasing community capacity, protecting areas, and community efforts. And the last one is like multi-stakeholder management for conservation is like so important. Maybe next slide. This I want to show to you. It's the NGO, the government, and villagers work together for the protect the forest. Thank you.
Thank you, Mr. Nanjo. Very interesting talk. But you use all the time for these sessions.
Sorry.
Any question? Just one short question? No, I think it's clear, but maybe we can discuss further on that one because it's such an interesting project like this one. So thank you again, and I would like to give applause to Mr. Nando for the talk. Thank you very much. The last but not least, I would like to invite Dr. Matthew Strubik. Pak Matt, are you there? So I would like to invite him that he would like to give a presentation on bird diversity in the forests and coconut farms of Sulawesi, Indonesia. Halo Pak Matt, apa kabar?
Hello. So I just tried to unmute the microphone.
Okay.
Apa kabar, Doni? Hello,
very
everybody.
good, thank you. Yeah. So you have 10 minutes for the talk, the presentation, and after that 5 minutes for the Q&A. So time is yours, Pak Matt.
Okay. Do you need me to share my screen, or you have the
I don't know. Can you share the screen from your side?
Yeah, absolutely.
Okay, you can do it, please. Okay, it's easier for me. Okay, time is yours, Pak. 10 minutes.
Okay, thank you. Okay, hello everybody. My name's Matthew Strubig, and I'm from the Durrell Institute of Conservation and Ecology at the University of Kent. Sorry I can't be there in person, but if you'd like to learn more about studying, working with us in DICE, please speak to Ardian or Namrata, who presented earlier today. So I'm going to tell you about some work that we've been doing with Universitas Indonesia and Universitas Gorontalo in Sulawesi about bird diversity in coconut farms. And this is part of a collaboration that we've been doing as the Newton Wallacea research program. Before I do that, I've got a quick advert for people in the room. Most of you know the team in DICE for their mammal work, and we're actually looking for new collaborations in Java. And we're looking to set up 3 camera trap studies in different parts of the forests of Java, ideally with existing camera trap data. And we have some funds available to supply cameras for a follow-up survey, but we need to get that started before May 2024, so next year. So if you're interested to work with us, I know some of you have already spoken in the room, then please contact me or speak to Ardian, who's also in the room today. And before anybody worries about it, yes, we do have the permits. So back to birds. So this work was led by Ibu Nurul in Universitas Indonesia, working with Simon Mitchell in DICE, with Pat Zoll and Bisma and Caleb were in the field, and the rest of us were helping with the analysis. If you want to learn anything else about the Newton program, you could follow the link here on the slide, and it will take you to an animation all about the program. So agriculture leads to the simplification of our ecosystems, as we can see from this figure here from Yudin Damali several years ago. And this has big impacts on biodiversity. And the key message from this slide is that the amount of management, or how intensive the management is in the farmland or the agriculture outside the forest, it leads to different outcomes for biodiversity. And so we want to know how coconut farming affects this process. So how does coconut farming influence biodiversity? And there's actually surprisingly few studies about coconut farming. Many of you will know me or my team for working on oil palm. We decided to work on coconut in Sulawesi because there's much more coconut there, and it's much more important to the lives of people in Sulawesi. And some estimates have been published that show that coconut farming potentially threatens more species than oil palm agriculture would do, because a lot of coconut production is on islands with many endemic species, such as Sulawesi. So we set up a study in Sulawesi, in Gorontalo, looking at birds in coconut farms, in forests, and in mixed farmland. And the mixed farmland was mostly corn, but other crops grown as well. And we worked in 3 landscapes, everywhere from Nantu Wildlife Reserve in the north to Boganinani in the east, and the agriculture landscape around there. In each landscape, we had 2 transects, and in each transect, we had 9 point counts that 200 meters apart that were done every morning. And those point counts were repeated 4 times. So we had repeated data. So we had 54 point counts in total, and each one was sampled 4 times. In any given day, we sampled forest, coconut, and mixed farmland, a mix of sites. So these are the other results. Here I'm showing you rarefied species accumulation curves. So if we compare diversity between different sites or different places or different treatments, it's really important to control for the sample effort and the sampling size, and rarefaction helps us do that. So if the confidence intervals on these curves overlap, that can tell us that the species diversity is actually quite similar between the different places. So here we can see on the left that the 3 curves overlap in the coconut, the forest, and the mixed farmland, the different color curves here, which tells us that there are similar numbers of species of bird in each of those habitats. But then we split the community based on the endemic species and the non-endemic species, so the second and the third graph here, and we can see that there are fewer endemic species found in the coconut and the farmland, and the agriculture tends to be dominated by generalist species. Here I'm showing the same rarefied estimates, but as a bar chart format, and we did this for Shannon diversity and Simpson diversity, and it tells us a similar pattern. So coconut farms tend to support lower bird diversity and bird evenness compared to forest, but they tend to be intermediate between the forest and the mixed farmland. So they're better than other agricultural types, but not so good as forest. Next, we undertook an ordination. So this is non-metric multidimensional scaling, which is a very long word for a very complicated ordination, but you can do it now. And it's very useful to look at the similarities and differences in biodiversity data between sites. So each of these plots shows each point on the plot is a point count location in bird community space. So we can think of these points floating around the plot, reflecting how many bird species and the abundances of the species in each of those sites. So the closer together the points, the more similar they are in terms of bird species composition, and the further apart they are, the more different they are. So you can see the locations are color-coded and shape-coded based on the different habitats, and you can see there's a lot of overlap between the habitats, but they're actually significantly different in terms of species composition. And there's much greater variation in the endemic fauna in the coconut and farmland, and the non-endemics tend to be similar across most of the agricultural areas. So what kind of birds do we find in each habitat? So we ran an indicator species analysis to find out, and this is quite a traditional analysis in community ecology. It looks for unusual abundance patterns in preconceived treatments or habitats. So we code in the analysis that there is forest, there is coconut, and there is mixed farmland, and then the analysis will look for unusual abundance patterns of the species there and tell us if they are significantly unusual, I guess. And what we can see on the left are the significant indicator species in the forest include endemic, such as the black-crowned white-eye and the Sulawesi babbler. And while the coconut and mixed farmland areas have indicator species that tend to be found in many generalist habitats. So things like spotted dove or lesser kukar, which are found all over South or Southeast Asia. Now, I don't claim to be an expert on birds, but I know the one on the right here is a tree sparrow, which I've got outside my window right now. And they're found all over Europe and all over Asia and in the coconut plantations in Sulawesi. So they're generalist species and they're far ranging. They've got a large distribution. And this is a pattern that we pick up in other places in Sulawesi and Maluku as part of the Wallacea program. And the sites are undergoing a process of what we call biotic homogenization. So this is the process through which species invasions and extinctions increase community similarity between sites. So you can think of this as the rich biodiversity-rich forests of Sulawesi and Maluku losing their endemic species when they're cleared to the farmland. So the farmland tends to be, the agricultural areas and the coconut tends to be dominated by disturbance-tolerated species that are found in disturbed habitats all over Southeast Asia. So several of the species that we find in the coconut plantations are also found in Seram, they're also found in Talaud, they're also found in Borneo, they're also found in Java. So one way to think of this is that the once diverse biological communities in the forest go into a blender, a homogenization blender, to form much more simple communities comprising the same species that are found everywhere else. So next time you're having jus buah, you can think of the biotic homogenization blender on this slide. So what will we do now? What are the next future steps? So we have a new PhD student from Sulawesi, Robbie. He's going to join the team in a few weeks to continue the work on coconut. And he's going to be working on an interdisciplinary study of the importance of coconut farming for biodiversity, but also for people's livelihoods. So he's going to be working with people in Sulawesi to work out how important coconut farming is to the environmental incomes of communities, and if there is anything that can be done to improve the environmental services around the coconut. And we're also going to be looking at what the impacts of coconut, both positive and negative, are at scale across the whole island of Sulawesi. And to do that, we've just been working with some of the colleagues in other universities, and we're about to publish a global map of coconut coconut plantations, including many of the validation sites were in Indonesia. So that's actually online and available public access at the moment, but it will be published in the next few months. But anybody who's interested in the map, I can send you the link and anybody can download it. We have a similar map for oil palm, and now we've got a map for coconut. It's very good at discriminating for closed canopy coconut. It's not as good for identifying areas that are very sparsely planted with coconut. Okay, so if you're interested to learn more about the bird diversity research that we've been doing in Wallacea, you can access for free these 3 papers using the QR codes here. So the first one on the left is the coconut study that I've just presented to you today in Oryx. And then the comparison across islands in Sulawesi and Maluku was published in Ecography last year. That's in the middle one here. And then last, we wrote a large review with 50 people across Indonesia and other parts of the world about the importance of Wallacea region and the conservation actions in the region that are quite specific to Wallacea, not seen in other places as much. And that is in Bioscience. So again, you can access that for free. If you have any problems accessing the links, just let me know and I can come back to you. So thank you very much for listening today. I'm happy to take any questions.
Thank you very much, Matt. Always interesting to hear your talk, and you are about 1.5 minutes late, but it's okay. We still have.
I thought I was early.
No. So we have like one short question. You have any question from the audience here, or maybe the online audience? Because I am being taught by the committee, there will be another talk by Pak Wiratno by 3:45 in this room. Any questions? I would like to ask question, but later on maybe, because this is quite interesting to see. Because, but I think as always, Pak Matt is there, and then all the students here, and so we can discuss further. So thanks again, Pak Matt. So if no questions, then I would like to give applause to Pak Matt for this interesting talk. Thank you, Pak Matt. So I think that's all. And as chairperson, I would like to thank to all the speakers in here, and also all the audience here that also hearing this talk, and such an interesting talk and the discussion. And I'm sorry for any inconvenience for during facilitating this the sessions, and I would like to give this to the MC. Thank you very much, and thank you.
Okay, thank you very much for Mas Doni Gunariadi. And I would like to apologize about the misspell Mas Doni name in the opening. Once again, please give applause for Mas Doni Gunariadi. Okay, ladies and gentlemen, we invite you to enjoy the coffee break, and you can try the snack and drinks in front of this room that has prepared by the committee.
All right, ladies and gentlemen, first of all, I'd like to thank all the presenters and, of course, Mr. Doni Gurnayadi as our distinguished chairpersons. And today, for the next session, the attendees are welcome to the coffee breaks for, I think, 15 minutes. We can start now, and refreshment will be served at outside. So please note that after the coffee break, at 4 o'clock, we would like to hold another sessions with our keynote speakers. So please enjoy and see you in this room again. Thank you so much. Give applause to us.